Today we're going to be talking about how to find the area of rectangles that use mixed numbers as side lengths.
First of all, what is area? Remember that area is how much space a two-dimensional or flat object takes up. So this rectangle here, if I wanted to know the area, I'm trying to figure out how much space does it take up? Sort of like, what's the colored part that I'm doing here? How much space is that? Don't get this confused with perimeter. Perimeter is the edges. It's that green line that goes around that. When I'm thinking about calculating area, there is a very helpful formula that's going to help me anytime I'm trying to figure this out, which will be all day today. So you'll want to remember this. It is area equals length, which I'm going to abbreviate to L, times width, which I'm going to abbreviate to W. You're going to be using this formula here quite a bit today, so you really want to commit it to memory. Let's say I have a rectangle like the one shown here. It is 5 feet across, that could be the length or the width, doesn't matter, up to you. And it is 6 feet going up and down. Again, that could be the length or the width. 6.5 feet, I'm sorry. And we're trying to figure out what is the area or how much space does it take up. So I'm always going to start by writing down my area formula. And then I'm going to swap in the numbers for the length or the width or the area depending on what I know in the problem. For this problem, the parts that I know include the length, which remember can be the 5 or the 6.5, whichever you like. So I'm going to put the 5 right in here. And then the width I know is 6.5. And remember, you can switch those because you can multiply in any order. It doesn't matter which one's which. All right, so my problem now is 5 times 6.5. Now, remember when we learned to multiply whole numbers by mixed numbers? It's really 2 problems. I have to do 5 times 6, then I have to do 5 times 1/2, because a mixed number is really 2 parts. So I'm going to go ahead and write out the 2 parts I need to do. All right, 5 times 6, that's an easy one. It's one of my basic facts. It is 30. 5 times 1/2. This is saying 1/2 5 times. 1/2 plus 1/2 plus 1/2 plus 1/2 plus 1/2. Now I know that when I'm adding fractions, the denominator doesn't change because that just tells me the size of the piece. So I still have halves, but I have more now because I've added it many times. I know that 5 times 1, or 1 plus 1 plus 1 plus 1 plus 1 is 5. So this is going to give me 5 seconds. Now, normally I would go ahead and just put my 2 pieces back together, but I noticed that there's something a little strange here. This is an improper fraction, so I'll need to change it over to a mixed number before I can put my pieces back together. So my first task here is changing 5 seconds into an improper fraction. One option would be to draw it. Let's see what it looks like. I'm going to draw some fraction bars. I can always add more or erase if I don't draw the right amount, so just draw 2 or 3 to start. And my denominator is 2, so that means I need to split these all into 2 pieces or into halves. My numerator tells me how many to color. I'm going to color 5. 1, 2, 3, 4, 5. Now that I've drawn this picture, I can really easily tell what this is going to be as a mixed number. I see 2 whole bars colored, so I'm going to go ahead and write my big 2. And then the fraction of the bar that's colored in the last one is 1/2. So I'm going to write 1/2 next to it. So I have effectively changed 5 seconds into 2.5. Now, I'm just going to cross this out so I know I'm done with it. I'm not going to get confused about that. I need to put the 2 pieces back together. So I've got 30 plus 2.5. Now, 30 and 2 are both whole numbers. I can add those together. That would give me 32. And then I've got a half plus no fraction over here, so that's just a half. So I was able to figure out that 5 times 6.5 would give me 32.5. So that's the space that that rectangle is going to take up. And if I had units here, like if I had known that I was measuring in feet perhaps, then I would want to add units to my answer as well. Remember that with area, it's square feet because it's taking up the length and the width. I'm sort of measuring in two directions at once. Let's take a look at another problem. Let's say I have a small piece of paper that measures 4 inches by 2 2/3 inches, and I want to know what is the area of this, or how much space is it going to take up. I'm always going to start with my area formula, and then we'll swap in the things that we know. So I know the length, it's 4, or it could be 2 2/3, whichever you like. I'm going to put in my 4. And I know the width, it's 2 2/3. And my formula tells me I'll need to multiply these together in order to figure out what the area is. Don't forget that multiplying whole numbers by mixed numbers is really 2 steps here. So I need to do 4 times 2 and 4 times 2/3. The first part, 4 times 2, that's easy. I know that's 8. The second part is where it gets tricky. 4 times 2/3, that means 2/3 plus 2/3 plus 2/3 plus 2/3. I still have a certain number of thirds. The size of the piece isn't changing, but I do have a lot more now. To figure out how many I have, I'll want to do 4 times 2. I know that that gives me 8. Now I would normally go ahead and put my two parts back together, 8 plus 8/3, but wait, 8/3 is an improper fraction that will need to be converted to a mixed number before I add those back together. So now I'm trying to figure out what 8/3 is as a mixed number. I could think about how many times does 3 go into 8. You could use your multiplication facts here, or I could draw a picture. I'm going to start with 2 or 3 bars here. Remember, you can always add more or erase some if you don't do the right number. And I need to split them into thirds because my denominator is 3. And then my numerator says I'll need to color 8 of them. 1, 2, 3, 4, 5, 6, 7, 8. All right, now I'm ready to name what this fraction is. So it looks like I've colored 2 whole bars. So this is equal to 2 wholes. And then I've got a fraction on my last bar here. It looks like I've got 2 out of 3 colored. So that'll be the fraction part. So I've changed 8/3 into 2/3. I'm just going to cross out 8/3 because I've rewritten it in the form that's really better, and I don't want to get confused and think that I haven't dealt with that yet. All right, final step. I need to add together the 2 parts. So I've got 8 plus 2 2/3. Whole numbers can be added together, so 8 plus 2 will give me 10. And then I've got 2/3 plus, there's no fraction here, so it'll just remain as 2/3. Now remember back to the problem, these were inches I was measuring in. So I do want to add inches, and it's square inches, which I can either write with that little 2 as my exponent, or I can abbreviate and write SQ for square inches. That works too, whichever one you like. First, I always need to think about my area formula. I'm going to switch in the units that I know. Usually it's the length and width, but it might not always be, so I want to pay attention to this. Remember that when I'm multiplying mixed numbers, like say 3 times 1 1/2, this is really 2 problems. You're doing 3 times 1 and 3 times 1/2. When you're multiplying the fraction times the whole number, you might get an improper fraction. So watch out for this. Pictures can really help move improper fractions into mixed number. Finally, you'll want to add all of your numbers back together. For example, in this problem, my 2 pieces I'd add back together are 3 and 1 1/2. So in the end, you'll end up with one number here. I got 4 1/2 for this problem. And then, what about units? Is it inches? Is it meters? Is it feet? Go back to the original problem and double check. Make sure that you use units squared. Now you're ready.